you will go through those notes. Those notes are basically made from the textbook. However, there are many other good books also. So if you are inquisitive enough and you find out time enough, so you will also go through these books. If at all you consider at home with these books. So the first book is written by Sandler, which is Chemical and Engineering Thermodynamics. It is a very good book, and it is available in our department library also. It is available in the National Library of Engineering Sciences also. It is a excellent book. However, a little, I would say, difficult as compared to your book. Then another good book is by Dobert, T.E. Dobert, which is again related to chemical engineering thermodynamics. The fourth one is written by Macquarie and Simon, which is a little different book written from the perspective of science, which is now called molecular thermodynamics. This is also a good book, but not very much related to our course. The other very good book written in a very colloquial manner and very informal way is by a person whose name is Octave Levenspiel. The name of the book is Understanding Engineering Thermo. Only first edition is available because this person is no longer living. The book is very interesting and very good book. However, we cannot make it as a textbook. So for people who want to study more, so they should go through these books, especially number 2 and number 5. Now, how are we going to divide this course? Basically, as I have already told you, there are two courses which you are going to study in your 4-year course. One is this one, the other would be Thermo 2. So maybe the other teacher, you would also go through this same book, which is Introduction to Chemical Engineering Thermodynamics. So as you see that we are going to follow this book. So the Thermo 1 will also be mostly from this book. And the course description which I have written here is exactly as it appears in the legal document, which is the course outline for the undergraduate courses. So I have written as such all these things which are present in that document. However, once we begin our study, we are not going to go strictly in a way as it has been written here. We will actually bypass, or sometimes we will actually go into a little more detail as compared to what has been written here. If you see, there are 5 sections, 1, 2, and up to this 5. So the first is the introduction, which is actually the first chapter of your book. So we will study the first chapter to cover this course outline. The second one is thermodynamics laws and their application in chemical engineering processes. So basically, we are going to study the laws here. So there are primarily 4 laws right now of the thermodynamics. You have also studied these laws in your FSC classes in pre-engineering. The first law of thermodynamics is related to the balance of energy, and the second law of thermodynamics is related to the balance of another property which is called entropy. Then there is another law which is called the third law of thermodynamics, which is again related to entropy changes and its calculations. And there is a fourth law also, which is very primitive. Actually, it is not called the fourth law. It is called the zeroth law. Zeroth. Because as such it is a very basic law. So, but it was actually discovered or written in a statement later on. So that is why it was called, being a very basic law, it was not called the fourth law, but it was called the zeroth law. So hence we have 4 laws now: zeroth, first, second, and third. We will see these laws later on, but if you see this article 2, thermodynamics laws and their application in chemical engineering processes. So this is actually the second chapter of your book. The whole second chapter will deal with the first law. First of all, we will discuss the first law for closed systems, and then we will discuss this for the open systems. We will discuss very important terminologies, for example, state functions, equilibrium, phase, what is phase, and a very important rule which is related to the phases, that is called phase rule. Then we will discuss the kinds of processes. Two very important kinds of processes in thermodynamics are the reversible processes and irreversible processes. Then the second law is discussed, but this is not in chapter 2. Now, beginning from this F, you are actually discussing chapter 5. So, after discussing or after going through this second chapter, we will not jump on to the fifth chapter, but we will actually go through the third chapter first of all, which is related to ClO1. So, I take a break here at point F, and let's discuss this point 3, which is actually your third law, third chapter. So, volumetric properties of
सॉरी
pure
मैम,
fluids.
एक्सक्यूज
Now,
मी मैम, कुछ बच्चे लॉबी में हैं तो वो कह रहे हैं उन्हें एंटर कर लें प्लीज।
आप कौन बात कर रहे हैं? ओके।
ये हैरानी की बात है सर, बगैर इंटरनेट के क्लास में।
हाँ जी, अब आ रही है आपको? मेरे ख्याल में ज्वाइन हो गया सारे।
नहीं सर, कुछ स्टूडेंट्स कह रहे हैं हम लॉबी में हम
सर कुछ
एंटर नहीं हो
स्टूडेंट्स
रहे।
लॉबी में वेट कर रहे हैं।
I think there is no one. All have joined. So I'll do it again, then there is problem with my teams. I can't do it again and again. Those students, if there is still anyone left, so I will send the recording also. You can listen to that. But please let me go through this first lecture, uh, because actually we are now right now short of time. So can you listen me now?
यस सर।
जी
Yes, sir.
Okay. So then we will go through the third chapter, which is the volumetric properties of pure fluids. So as you can see from the name, we are going to discuss the pure fluids in this course. We are not going to discuss the mixtures. The reason is very simple, because it is the introduction. Now, when you are introducing yourself, so you will actually first of all study the simple things. The mixtures are more important from chemical engineering point of view. However, to begin with, the understanding of the properties, first of all, you must understand the properties of pure fluids. Now, what are the volumetric properties? The volumetric properties are actually all those properties that are related to the volume of a fluid or a substance, which can be volume itself also, or some other properties related to the expansion and compression of a fluid, which will obviously change the volume. So here we are going to discuss certain very important aspects. in a way to find out these properties, we will have to have some mathematical formalism, or some equations are there. So those equations are actually called equations of state, which is written here as EOS, equation of state. There are many equations of states, the simplest being the ideal gas equation of state. However, here you are going to discuss real fluids, so we are going to discuss some other forms. For example, virial equations of state, then cubic equations of states, and then we are going to discuss some other relationships which are very generalized. Why are they generalized? We will discuss in the chapter, and their name is also generalized correlations. Then in thermodynamics, the way you carry out a process will change the energy requirements. If you carry out a process in a certain way, for example, keeping the temperature of the process constant, you call such a process as isothermal process. If you carry out a process keeping the pressure constant, you call it an isobaric process, so on and so forth. So the way you carry out a process is important. So there will be a description of the kinds of processes also, of which only one generic form is written, which is the polytropic process. However, we will discuss all these processes here. Once you have gone through this, then your first three chapters will be concluded, which is going to cover these 3 points: first point, second point half, and the third point. So this is actually your CLO1, and then you will appear in your midterm exams. After your midterm exams, we will switch on to chapter 5. We will not discuss chapter 4, though it is an important one, but it is not part of your course. We will discuss then chapter 5. And in chapter 5, we will begin with this point F, which is the second law of thermodynamics. Now, in this chapter 5, we will discuss in detail the second law in a similar way as we discussed the first law in second chapter. Now, the second law will be discussed for closed systems, and then it will also be discussed for the open systems. We will discuss a new function, a state function, which is required to write down the statement of the second law, that is called entropy. So we will discuss this concept, the concept of entropy, and what is the importance of this function in thermodynamics, and how do we calculate the changes in this property, for instance, for an ideal gas or for a real substance. But in chapter 5, we will only remain up to the ideal gas. Then we will discuss a special kind of calculations which are required to find out the efficiency of machines or processes. So they are actually the calculations of work and heat. The calculation of work will be the main framework behind this chapter 5. So we will discuss how a process or how a machine can carry out maximum amount of work, or if it requires work, it requires a minimum amount of work. That is called the ideal work. And the lost work is actually the work which is lost, or energy which is lost due to the inefficiency of a process or a machine. So these two concepts will be discussed in relation to the second law, because they are actually inherently related to the second law. Then the third law, which is more important for physicists, however, statement and a basic understanding of the third law, which is also required, will be given within this chapter 5. This will conclude our fifth chapter. Then we will go to point 4, which is the thermodynamic property diagrams and tables. In this chapter, which is actually not only related to the diagrams and tables, which it is actually a very important chapter. The sixth chapter is actually the mathematical foundation of the thermodynamics, and you will devise or derive many equations, beginning with the two equations, the first law equation and the second law equation. And we will develop a framework of the thermodynamics. However, under the current scenario for your session, this chapter will be discussed in thermodynamics too. But little thing about the diagrams and tables which are required at this level needed to be discussed in our course. So we will not study chapter 6 in detail. However, we will study only diagrams and tables and how to find out the properties from these diagrams and these tables. And now on with the advent of these computers, you can also find out the properties using many freewares and softwares. So as such, the diagrams and tables are kind of obsolete now. However, being an engineer, you must know how to read these diagrams and tables. Once we have gone through this, which we will go, let's say, one or two lectures we'll spend on this sixth chapter, in which we will discuss the diagrams and tables. After this, there are two new chapters which will previously discussed in thermo 2, but because right now you also have thermodynamics lab, and in the laboratories you are going to discuss the power cycles and refrigeration cycles. And there are two chapters which are devoted to the production of power and the refrigeration. These are eighth and ninth chapters of your book. So we will discuss in this fifth point. These last two chapters will be discussed. However, these chapters as such written are very small and very intricate. So no notes will be given at this point. So we will do the reading from the book straight away for these chapters 8 and chapter 9. And these will actually form the your CLO2. So in power cycles, you are going to discuss how you can use some source of power or energy to generate some power. For instance, you might use natural gas, or you can use the power of a dam, which is called the hydrothermal hydrodynamic cycle, or you can use the power of steam, which you can make from, let's say, combustion of some fossil fuel, for example coal. Or there are many other ways. For instance, the direct use of the combustion gases can be there, for instance in a jet engine or in a rocket engine. So all these engines will be discussed in the eighth chapter. Then finally, a very important aspect or very important application is in the refrigeration. So how does a refrigerator work, and what are the different kinds of refrigeration cycles? You will discuss this. And in the liquefaction, which is again part of this chapter 9, so we will discuss how to liquefy some fluids by maintaining low temperatures. So different kinds of engines. The basic ideal engine is called the Carnot engine. First of all, we will discuss this engine. Then a little non-idealized engine, which is called the Rankine engine or the Rankine cycle. Then the real engines, for example, the internal combustion engine, which are present in cars, automobiles, trucks, etc. Then the cycles of vapor compression and absorption. This is actually your ninth chapter, which is the two important refrigeration cycles, the vapor compression and absorption. Hence, here we are going to conclude our course. So within these 6 months, out of which probably we will study for only 4 months, we will try to finish this course as much as possible. So how what are your objectives now? First of all, the three laws of thermodynamics, the zeroth law and the third law are not very important for us in from the point of view of application. So the first law and the second law and their application also. This is our first objective, because once you develop an understanding of the first and second law, then you can solve many problems related not only to thermodynamics but also to allied branches, for example heat transfer, which you will study in your senior classes. Then the volumetric properties of pure fluids, which is a little different aspect as compared to the study of laws, which is you are going to discuss in your third chapter. Then thermodynamic properties of fluids. which is chapter 6. However, not in depth. The only thing which we are going to discuss in this chapter are the diagrams and tables. And then finally, 8th and 9th chapter will be studied straight away, completely from one word by word. We will study this and we will study from the book. So the power generation from heat is chapter 8, and refrigeration and liquefaction in the next chapter. There are two CLOs, so course learning outcomes. As you know, you are following the outcome-based education system, so you must know what are the two CLOs for this course. The first CLO is related to the basic concepts, the first law, and volumetric properties. So basic concept means the first chapter, first law means the second chapter, and volumetric properties means the third chapter of the book. The domain is actually C2, कॉग्निटिव है, और सेकंड इसका लेवल रखा हुआ है. PLO1 है, which is the engineering knowledge. The second CLO, which is post midterm, we are going to apply the laws, and we are going to apply these laws at the systems level. The systems would mean a certain kind of a machine or a certain kind of a process. And we will also discuss this second law in the CLO2. So this is related to cognitive level. The level is a little higher because we are going to apply this. So this is C3 and the PLO is second. So hence we will discuss or we will try to cover, or we will come to the outcomes. Will be two outcomes and covering the two PLOs, and you will be needed to obtain at least 50% marks in each of the CLO in order to obtain a satisfactory passing criteria. Now the week wise course outline is written here, in which I have tried to manage to finish, let's say if you talk of pages, so 4 to 5 pages per lecture. However, it all depends upon the way we are going to follow the course. If we are going online, then I will share my notes, and we will try to finish one kind of a note in one lecture, in which the first 2 weeks, as written here, are from the first chapter. So as such, I have written the other books also. For example, book 2 you can use, book 4 and 5 you can also use. However, try to stick as much as possible to the notes and the first book in order to develop the understanding. Once you are comfortable with the first book, then you can switch on to the other books also. If you are going online, then I will try to manage to hold some vivas during the class, or I will try to manage to give you some homework, and then you will send me a picture of your work so that I can check that. Mostly regarding the examination point, because the outcome is that you are able to solve the numericals. So we will actually be grossly solving the numericals at the end of the each chapter. So nevertheless, my focus will be on the theory of the subject so that we can develop a good understanding of the subject. However, the outcome which is required from the student side will be, there will be two types of outcomes. Once you will be checked from theory point of view also, but majorly you will be assessed from the point of view of numericals. So both are required, but problem solving is a very important aspect of our course. So if you are given some kind of homeworks or vivas or quizzes, they might be related to the numericals, not only to the theory. So first of all, the first chapter will deal with the very basic things. For example, the dimensions, units, measures of amount and size, what is force, what is the notion of temperature, what is pressure, and two very important things which are the forms of energy. One is work and the other is heat. So what is work? How do you regard work as a form of energy, and what is heat? How do you regard it as a form of energy? Primarily, initially, people regarded work as a form of energy, but heat was historically not regarded as a form of energy. But later on, as we will see in the second chapter, after the experiments of many scientists, for example, Joule, heat was also regarded as a form of energy. Then, beginning from this second week, after the problems and reviews of the first chapter, we will try to begin with the second chapter within the second week. So a very important concept is the concept of internal energy. That will be discussed first of all, so that you can write down a statement of the first law. So before you write down the statement or understand the first law, you have to understand another kind of energy, which is called internal energy. So now, right now, we have three forms. One is work, the other is heat, and the third one is the internal energy. So if we have these three forms, we can write down a statement in which we can equalize or equate the internal energy to heat and work, and that form of written form, either mathematical or in words, that is actually called the first law. Now we begin with this first law, and we keep on studying this first law up to, let's say, this fifth week. So these second, third, fourth, and fifth week will be for the are planned actually for your second chapter. Now there are many important concepts which are not very basic, but probably you have discussed them in your FSC classes also. For example, the two types of processes are reversible and irreversible. So what are reversible processes, or what are irreversible processes? So for that you have to understand through some example, because writing as such or defining a reversible process would not give you a good idea of this process. So you have to come up with some examples which are given in the book, and we will try to discuss the reversible process. And within that context of a reversible process, we will also discuss the state of equilibrium. And when we discuss the state of equilibrium, naturally the thing which we are going to discuss afterwards would be phase rule. So all these three terms, the reversible process and the equilibrium state and the phase rule, are actually related to each other. So once you discuss these three all together, then you can actually grasp a very good understanding of the thermodynamics. Then there are many important processes which we are going to discuss, but two very important processes are constant volume and constant pressure. Another important term of energy is the enthalpy, which as such is a derived quantity, because the primitive quantities you have already discussed, that are work, heat, and internal energy. Primitive means the old ones, or in context of thermodynamics, the primitive would mean something which you cannot actually define. However, you can define some new properties which are actually combination of these properties. So for example, enthalpy. Once you are doing your energy balance calculations, which is actually formally the first law, so you will need some more symbols. So instead of internal energy, we will define a new property of enthalpy. Another important property would be heat capacity. So after this, we will discuss the energy balance for open systems, and this will actually give us an opportunity to solve many problems which are more common in chemical engineering practice, and that will be actually discussed in the problems and examples of the second chapter. So by the end of the fifth week, it is hoped that we would finish the second chapter. And then the third would be your pressure, volume, and temperature, PVT behavior of pure substances, which is actually also called the volumetric properties. The name of the chapter is volumetric properties. In this, we are going to discuss, first of all, why are we going to discuss pure fluids? We will discuss that thing. And what are the different phases, जो आप पढ़ते हैं, for example, solid, liquid, gas. What is the meaning of this solid, liquid, and gas in context of thermodynamics? When do you call a substance as a gas? When do you call a substance a fluid? When do you call a substance as a supercritical? When do you call a substance as subcritical, etc., etc.? So these are very important terms for from the point of view of thermodynamics. Very good understanding of the phases is required. Before moving on to the quantitative aspect in which you will solve the numericals, first of all, our few chapters of the chapter 3 will be the qualitative discussion, in which we are going to discuss the phases of a substance. And then we are going to discuss, first of all, simplest fluid in science, that is called ideal gas. So you will discuss the ideal gas as the simplest fluid, and later on then you can discuss the real fluid also. But remember that this is not up to only ideal gas. You might be very familiar with the concept of the ideal gas, and which we will also discuss here also. However, this is actually a benchmark fluid which will actually give you an opportunity to find out the properties of the real fluids. So, first of all, you need to discuss the ideal gas. A question might arise: why are you going to discuss the ideal gas? Because there is no ideal gas in the universe. But then, why are you going to discuss this? The answer is actually a tricky one, and that will actually be related to the time or the slot that you study the course. Then you will realize why it is important to study the ideal gas. But as such, at this moment, I would say that unless and until you develop a mathematical formalism for thermodynamic fluid, which is the ideal gas, you cannot do it for the real fluids. So, or in other words, our mathematics as such is not very advanced, and you cannot write down the mathematics for the real fluid. The only mathematics that you can write in context of thermodynamics is for the ideal fluid, which is the ideal gas, and then you can compare this mathematics with the real fluid. So as such, this is actually the main point. However, in due course of time, we will also discuss many other aspects which are important to be discussed from the ideal gas point of view. And then those equations which are actually related to the non-ideal fluids, for example, the virial equations, the cubic equations, the generalized equations or correlations, these will be discussed as the major aspect of your course of the chapter 3. Then we will have to finish this before the midterm, I hope. And after the midterm exams, we are going to have the second law, in which we are going to discuss the heat engines. But before the heat engine, we are actually going to formally write down the second law. Then we will discuss the heat engines, in which the ideal heat engine would be the Carnot engine. The concept of entropy would be discussed. Quiz 1 will be taken, probably this will be taken before the midterms if you are here, or maybe afterwards if it is online. Then the chapter 5th would be concluded with the discussion of the works. From the point of view of the week 12, these are actually things which you are going to discuss in your chapter 6. And beginning on from 13th week, 14th week, these 2 weeks are reserved for the theoretical exams, in which we are going to have should be maybe presentations if the time allows, because sometimes students complain that they are not given an opportunity to present themselves. So this is actually maybe an opportunity. If the time allows, we will have presentations for the cycles and engines. Similarly, the last 2 weeks, if they are 15th and 16th weeks, these will be for the refrigeration and liquefaction. And again, if the time allows and we have enough resources, we will carry out presentations from the students to give us give us them an opportunity to present their themselves. And the quiz 2 will be held, and after which we will have the final exam. So this will cover your CLO2. As you can see, the post midterm is all CLO2, and the pre midterm is all ClO1. So this has been done deliberately so that you can spend equal opportunity, almost equal opportunity for both the CLOs. But minded that ClO1 is more basic as compared to ClO2, because those things which are related primarily to the application are discussed in ClO2, whereas the basic concepts are all covered in ClO1. So it is hoped that if you can clear ClO1, hopefully ClO2 would be easier for you. So I conclude my lecture here, and if you have any questions, please you can ask now.
Excuse me, sir. Sir,
Yes, please.
सर नेक्स्ट टाइम से जब प्रॉपर लेक्चर हो तो काइंडली रिकॉर्डिंग भी साथ कर दीजिएगा, मोस्टली स्टूडेंट्स
The
ये कह
recording, I will send the recording also. Yes, I will send the recording also. And regarding the attendance, actually, I can download this attendance list, and I can download the attendance afterward also. That is possible for me. However, I would request the two CRs to kindly make an Excel sheet for the time being that you are online. So kindly make an Excel sheet for me if possible, and I would ask all the students to let your CR know that you are present in the class. But I will also download the attendance from here also. So please do this needful for me. Okay.
Okay, sir.
ओके
So and yes, any question? Okay, next time
Sir,
I will.
सर अपना कॉन्टैक्ट भी काइंडली शेयर करो.
जी please पूछें.
sir, some students are not added in your team.
Uh, if they will send me request, I will add, but probably Mr. Amir, your sir Amir is doing this. He knows how to add the students. You can request him. He will add the students. If a request
Okay,
would
sir.
come to me, I will add you. I will make another channel next time. Today was a meeting in the general, but next time I will make a channel and we will begin the lecture in that channel. Okay?
Okay, sir.
सर ये स्लाइड्स लेक्चर की आप कहाँ पे शेयर करेंगे?
Yes, please.
ये स्लाइड्स लेक्चर की आप कहाँ पे शेयर करेंगे? टीम्स पे
हाँ
या
जी,
वेबसाइट पे?
मैं उसमें बनाता हूँ, चैनल बना के उसके अंदर रख देता हूँ. ठीक है, मैं आपको शेयर करता हूँ.
सर अपना कॉन्टैक्ट भी काइंडली शेयर कर दो.
Please a little loud.
सर काइंडली शेयर योर कॉन्टैक्ट नंबर आल्सो.
Contact number.
यस सर.
अच्छा, ठीक है. I will share it, but I seldom use mobile. I do not use mobile a lot. So
Sir, today also
I will
the
share it
meeting
with you.
meeting was unexpected. I mean, it started all of a sudden. We were not sure that we had a class or not.
No, but it was scheduled at 2 p.m. For me, it was not all of a sudden. How was it all of a sudden? It was written in your timetable. It had to be at 2 o'clock. Why do you say it was all of a sudden?
So students ये कह रहे हैं.
One thing, your one lecture is missing, so I will try to do a makeup lecture, because I could not attend the first time. I was a little busy at that time, right in the nick of that thing. So I think we need an extra lecture also. Tomorrow you have a lecture at 8 o'clock, and then thermodynamics, stoichiometry. At 11 you have stoichiometry. So we can have a lecture at 2 p.m. tomorrow. Sorry, not tomorrow, on Friday, or 2:30. Is it okay?
सर फ्राइडे को 2:30 से 4 तक जो है पार्टिकल टेक्नोलॉजी वाले सर ने कहा हो जाएंगे कि उनके
Okay, then
बिकॉज उनके भी काफ़ी लेक्चर्स मिस हुए हैं.
इनके
पार्टिकल टेक्नोलॉजी वाले सर डॉक्टर जफर.
नहीं, अभी तो हफ्ता शुरू हुआ, लेक्चर कैसे मिस हो सकता है?
सर ये पिछले वीक में जो मतलब ये वीक ऑनलाइन वाला जो गुजरा है उस वीक की।
नहीं, पिछला
सर
वीक, इसी वीक तो शुरू है, आप कौन से वीक की बात कर रहे हैं? आज
सर
जो
उन्होंने
है
मंडे और
वो,
ट्यूसडे को लेक्चर नहीं लिए, मंडे और ट्यूसडे को उन्होंने अपने लेक्चर्स नहीं लिए, तो वो लेंगे।
अच्छा ठीक है, तो फिर आप मुझे कोई और टाइम बता दीजिए। ठीक है, आप सीआर से डिस्कस कर लें, मुझे एक टाइम दे दें 1 घंटे का, जो लेक्चर आपका मिस है वो हम मेकअप कर लेंगे, ठीक है? इफ देर इज नो क्वेश्चन देन आई कैन लीव। Yes, no question. Okay, then Allah Hafiz.